All right, hello. We are going to get started here with chapter 7 for those of you that like to keep your notes really organized. The title of chapter 7 is Polynomial. That's a big word for you. We haven't talked about that. Polynomial equations and factoring. Okay, we're going to spend several days here on the first part of this, which is polynomial equations. And then we're going to spend even longer on what's called factoring, because that's something that pops up from here on out in your math career. So that's kind of fun. Section 7.1 is where we're going to start. Okay. And the title is adding and subtracting polynomials. That's the section title. Okay? And we're just going to talk about some definitions and do a few examples in this video. And then in class, we're going to talk about some more advanced things because I do like to have discussions still with you guys, and so I don't want to lose that. But before we can get started on any of these examples, this entire chapter and for the rest of your math career, we need to talk about some vocabulary. So up first, let's talk about the word monomial. Okay? This is a new vocab word for you. A monomial is a number, a variable, or the product. Remember, product means multiply. Or the product of a number and one or more variables with whole number exponents. Okay? And you're like, great, Bacham, I have no idea what that is still. So let's do some examples. Some examples here of monomials are 10. 10 is a monomial, right? It's a number. You could have something like 3x. That's a monomial. So that's kind of cool. You can have something like 1/2 ab squared. That's a monomial. And even though that there's a 1/2 an a and a b squared, that is still a monomial. And I think when I explain what a binomial here is in a second, you're going to understand that a little bit better. Okay? Negative 1.8 m to the 5th. That's a monomial as well. Okay? So basically, it's just whenever you see one term there, and there is no plus or minus sign coming after it. Okay? You just want one thing. All right? Okay, so now let's talk about that big fancy word, polynomial. Okay? And a polynomial is a monomial, which is what we've just talked about. A monomial or a sum of monomials. Okay? And you've seen these. We just haven't ever talked about them by definition before. Okay, so now we've got some sub-definitions. Not really. Sorry. Let's talk about now what a binomial is. Okay, a binomial is a polynomial with two terms. So an example of this would be something like 2x plus 1. That's a binomial because it has two different terms. Okay, a trinomial then is, you guessed it, it's got three terms. So it would look something like, I don't know, x squared plus 2x plus 1. That's a trinomial because it's got 3 terms, okay? And both of these and monomials, those are all polynomials, okay? Poly means many, right? A polymer in chemistry is something that's got many of something. I don't know, I'm not a chemist. And so a polynomial is just when you've got a lot of things added together. It's a very loose definition of that, okay? A couple other things. The degree of a polynomial, because I'm going to ask you, what's the degree of this polynomial, okay? The degree is the greatest exponent of all its terms. That's what a degree is, and I'll show you in an example here what it is. Okay? And the other thing here that you're going to need to know is what standard form is. Okay? Standard form means that the terms are in order based on the value of the exponent. And you want to go highest to lowest. Okay? So now let's talk about all of these things in an example. Okay? Let's say you had 2x to the third plus x squared minus 5x plus 12. Okay? This is in standard form because the greatest exponent, which is 3, comes before the x squared, which comes before the x, which comes before your constant term. Okay, so that's already in standard form. All right? This 2 up here, this is what we call a lead coefficient. Okay, and a lead coefficient is just the coefficient in front of your first term if you're in standard form. Okay. The degree of the polynomial, that's what we talked about up here, is 3. It's the biggest exponent that we have. So the degree is 3. Okay. And 12, I know I've mentioned this, but let's go ahead and label it. 12 is your constant term. Okay. So just a lot of vocabulary here to get us set up for Chapter 7. Okay. So now let's talk about those definitions in practice just a little bit. Okay. So we're going to make a little chart here. Okay. We're going to talk about the polynomial. We're going to talk about what it looks like if it's in standard form. Okay. We're going to talk about the degree. And then we're going to talk about the type. So we're just going to organize our thoughts here into a table. Okay? Beautiful. All right. So let's talk first about something like negative 3z to the fourth. Okay? And I'm actually going to start here with the type because obviously it's a monomial, right? And I know that there's a 3 and a z, but there's only one of them. Okay, there's only one term there. It's negative 3z to the fourth, so it's a monomial. Okay? The degree, well, there's only one power there. So we say it's a degree 4. All right? And because there's no other terms, it is already in standard form. It's already there. Okay? So that's pretty straightforward. But now what if I gave you something like 4 plus 5x squared minus x? Okay? So this is what we call a trinomial because it has 3 terms. All right? The degree, you're looking for the highest power, and the highest power here is 2, so it's a degree 2. And in standard form, that just means that we start with the highest exponent, which is 5x squared, and then we work our way down. And so the next highest exponent would be this one, so that's minus x. And then you finish out there with your constant term. Just be careful with the signs. Okay? What if I gave you 8q plus q to the 5th? Okay? This is a binomial because it has two terms. Okay? The degree here, okay, so the power is 1 if we don't see it. So we've got a power of 1 or a power of 5. We take the biggest one. This is a polynomial of degree 5. That's what we say. And in standard form, then, that means we take that highest exponent, we put it out in front, and then we work our way backwards, and that's all we got left there. Okay. Beautiful. It's just a lot of vocabulary at this point. Okay. Okay, now let's get into just two examples about adding and subtracting polynomials, which is what the title of the section is, but we couldn't do this unless we defined all of those things up there. Okay, so I'm just going to do two examples. We're going to do one addition and one subtraction because I think that you'll probably get the hold of it. All right, so example 1 here, I'll say something like, find the sum. All right, and then I'll give you something like this. Open parentheses, 2x to the third minus 5x squared plus x plus, and then parentheses, 2x squared plus x cubed minus 1. Okay, that's what an example would look like. And I'm hoping that you understand by now that when you've got all addition like this, those parentheses essentially don't matter. So if we were to take them away, nothing would change. So let's continue with that. So we've got 2x cubed minus 5x squared plus x plus 2x squared plus x cubed minus 1. Okay, and so now it's just this one big polynomial, which is fine. And so what we need to do now is just combine like terms. And like terms have two things. They have the same variable and the same exponent. Okay, I want you to write that on the side. Same variable. And put an S there because sometimes you're going to have more than one variable. Same variable and same exponent. Okay? So, and you want to write your answer in standard form, so you want to start with the highest power first. Okay? So if I start with 2x to the third, this is the other x to the third. And if I have 2x to the thirds plus 1x to the third, that gives me a grand total of 3x to the thirds. Okay? And if you've got negative 5x squared plus 2x squared, that gives you a negative 3x squared. And then we've got x here, and x doesn't have any other x's, so we just add it. And then that minus 1 on the end stays there too. So your final answer looks like this. You cannot combine the x cubed and the x squared because they do not have the same exponent. Okay? X cubed and x squared are what we call not like terms. They're not alike because they have a different exponent. Okay? That's adding. Same ideas are going to be again in this next one, except this time, for example 2, I would say something like find the difference, right? Because difference is subtraction. So we're going to find the difference here, okay, of parentheses 4n squared plus 5, close parentheses, minus, open parentheses, negative 2n squared plus 2n minus 4. Okay? Now, if we just look at this first term here, nothing matters if we take those parentheses away, right? Because 4n squared plus 5 is the same regardless if we write it with parentheses or not. However, we can't use that same idea on this next part here because this negative applies to this entire polynomial. So what you have to do is you have to take this negative and distribute it to all of those terms on the inside because you're subtracting everything. Subtracting means opposite, okay? So we've got a negative 2n squared, which creates a positive 2n squared. A negative positive 2n, which creates a negative 2n. And a negative 4, which creates a positive 4. Okay, so when you're subtracting, you have to take what's in that second parentheses and change all of those signs. All right? So that's kind of where we're at here. So now we can combine like terms. We've got 4n squared plus 2n squared, and that creates a grand total of 6n squareds. We've got a negative 2n, and that doesn't have any friends, so that will stay negative 2n. Okay? And then last but not least, we've got 5 plus 4, which gives you a grand total of 9. So your entire answer there is 6n squared minus 2n plus 9. Right? So basically, we're just taking what we already know from pre-algebra and the first semester of Algebra 1, and we're just kind of expanding on it, which is what you're going to see math kind of is from here on out. Okay? Study those. Let me know if you have questions, and we will move on tomorrow in class with some expansion of these ideas.